Welcome, and let us look at differentiation techniques. In our previous class, we looked at how to differentiate using definition of the word derivative. And today we'll be looking at other techniques which include the product rule and the quotient rule. So I begin with the product rule and I define it. I state what it says, that when given two functions which are differentiable, that is f of x and g of x, which are differentiable, then their product will also be differentiable. And that to get their product, to get the derivative of their product, you would have to take g of x, that is our second function, times the derivative of the first function, plus our first function times the derivative of the second function. So we look at examples, but we must know the definition. That's the definition, that the product, this is the first function and this is the second function. So their product, the derivative of their product would be the second function times the derivative of the first function plus the first function times the derivative of the second function. So we look at examples and we'll be applying product rule where there is a product of functions. Well, given two products, then we'll be using product rule. Now, for example, in this part A, we are given the first function is here, and then the second function is here, and we are supposed to use product rule to find the derivative of this. So we just use it, and note that this symbol here means it's a command to differentiate. So this one means differentiate this product. So let's differentiate our first function. So our first function differentiating, we get 10x raised to 4 minus 6x. This is a constant. Its derivative will be 0. Then our second function, we don't differentiate it, so it will be 7x cubed. 7x cubed minus 6x. Then this time, let us now differentiate our second function, and it will be 21x squared minus 6 times the first function. This time we do not differentiate the first function. So at this point, what we only need to do is to expand what we have. So multiply this with that, and then plus this times that. So 10x raised to 4 times 7x raised to 3 will get 70x raised to 7. And then this one will give us negative 60 x raised to 3. No, it's this. So this times is set to be x raised to 5. So this to x raised to 5. Now let's go to this times that to be negative 42 x raised to 4. Then this times this will be positive 36 x raised to 2. We are done with this, so we move to this part. So 21x squared times that, we get 42 42 x raised to 7. And this terms out we'll have negative 63 x raised to 4. And then this terms out we'll have positive 168 x raised to 2. 168 x raised to 2. This was, let's just repeat from here. This times this was 42 x raised to 7. Then this times this was 63 x raised to 4. Then this times this was 168 x raised to 2. That's correct. Let's now multiply by negative 6. So negative 6 times that would have negative 12 x raised to 5. Negative 6 times that we have positive 18 x raised to 2. Negative 6 times this will have negative 48. So we would now collect like terms. For instance, the one that has x raised to 7, I have 2 of them here, x raised to 7. So if you add them together, you would get 112 x raised to 7. So we are done with this. It's not, you don't need to cancel it, but I'm just doing it because it's long, so that I keep track of what I've added and what I've not. So I have x raised to 5 here and another one here, and putting them together we have 72 x raised to 5. So we are done with that. Let's come to x raised to 4. We have this negative 42 and this negative 63. So put together to be 105 x raised to 4. So I'm done with this and that, cancelling so that I keep track of what I've dealt with. Now I now have x squared, another x squared, another x squared. So 36 plus this is 102, 104, 104, no, 204, 204. Then plus this is 222. X raised to 2. So I'm done with this. So what is left? What is left is this negative 48. And that becomes the answer to that derivative. Okay, so let's clear this space so that we can do the next question here. Want to use the same space to do the next question. What does the next question say? The next question says the derivative of this times this. So again, we'll differentiate the first function to get 3x squared plus 3 then multiply by the second function, which is 5x squared plus x raised to a half plus 7. Then this time, differentiate this second function to have 10x plus half x raised to negative a half. Yes, when you subtract 1, then you get negative a half. And these are constants, so it will be 0. Then multiply by the first function. Let me just be sure that I'm differentiating for part B and not A, because you're likely to differentiate for part A when you're answering the question for part B. Okay, so I have x cubed plus 3x minus 5. So again, we just expand. Let's expand, and you can see that this will give us 15 x raised to 4. Just write it properly. The x, yes, x raised to 4. This is 15 x raised to 4, and that is 3 x raised to 5 over 2. And you know that when you multiply, you add the powers. So when I add 2 plus a half, that is how I get 5 over 2. Then this times that, I would have 21 x raised to 2. I'm done with 3. So 3x squared. So I come to 3 now. This would be 15x squared and this would be 3x squared. Which one is that? This was 15. This would be 3x raised to a half. X raised to a half. And then plus 21. We are done with these brackets. We come to the next one here. Just create enough space. Then go all the way to this other side. Now 10 times that would have 10x raised to 4. And this would be 30 x raised to 2. And this would be negative 50 x. Now let's multiply this to get a half x raised to 5 over 2. And you remember we're just adding the powers. So this would be 2.5, which is 5 over 2. And this, so which one was that? We did this. This is the one we've done, yes. So we are coming to this. 3 over 2 x raised to a half. Then finally, we have this times this, which gives us negative 5 2x raised to a half. 2x raised to a half. So let's now collect our like terms. I have 15x raised to 4 and I have 10 x raised to 4. So these two put together, and as I said, you don't need to cancel your working. I'm just bringing that to keep track of what I've used and what I've not. So these two added together, I get 25 x raised to 4. Let me come to x raised to 5 over 2. I can see this and this. So if I was to put them together, I would have 7 over 2. Because it's 3.5, 7 over 2. X raised to 5 over 2. Let me come to x squared. I have these two. They give me 36. Then I have this. So that gives me 66. X raised to 2. Okay. Let me come to x raised to half. I have this and this. So if I put them together, I'll get 9 over 2 x raised to half. 9 over 2 x raised to half. Just remember that we have this 21, but I want to put those that have x first of all, then I put a constant later. So the other one that has x, I have this 50. X. I've already used this, so I need to include this. 5 over 2 x raised to a half. And then there was a 21 plus 21. Now, if you want, you can leave the answer at this point, or you may want to put your results under the same denominator. So let's try to put them under the same denominator. But as I said, you can stop at this and you have the answer, correct answer. Now let's put this under the same denominator. And our denominator is 2x raised to a half. Just create enough space for my numerator. Denominator is 2x raised to a half. And you see that this is 1. So it will go into this one, 2x raised to a half. So 2x raised to a half times this would get 50. X raised to 9 over 2. These are 2 here. To go here, x raised to a half times. So x raised to a half times this would have 7. So just adding this plus this, because it's 2 that goes here. So when you do that, we get x raised to 3, because 5 over 2 plus 1 over 2 will be 5 plus 6 over 2. No, 5 plus 1 over 2. So that's what I get. And then there's a 1 here to go here this number of times. So if I multiply that, I would have 132. x raised to 5 over 2. And then of course this one will give us, and it was negative. It was negative 50. I can see it was negative 50, not positive 50. So this one is supposed to be negative. It was negative from this point. And even the other negative was here. The other negative was here, and it's this one. So again, that is supposed to be negative. This one is supposed to be negative. It's here. So I can see the two negatives, this and that. So they're equilibrium. Now, so this and therefore, one goes here this number of times, we'll have negative 100 x raised to 3 over 2, because this is 1 plus a half, and then minus 5. I can just put plus 21 here, so that 21 is not under the denominator, is not under this denominator. But if you want to put it under the, if you want to put it, no, where it is, it has no denominator below it. It has no denominator below it. So if I want it to be above here, then it must be 42 x raised to a half. 42 x raised to a half if it were to be here. Have we left this one out? This one we have left it out. 2 goes here. X raised to a half times. So multiply by that, I would have plus 9x plus 9x. So we had forgotten this here, because I can see we have done this 132, then from there we came to 50 and we forgot this. So let me just create this space that we do question 3. Okay, question 3 is very easy, so let's do it. So again, we just differentiate the first function, and doing that, we see the first, that one is the same as x raised to 3 over 2 plus 5. This is what we have, plus 5 multiplied by 2x squared plus 5x. This is what we have. So now the derivative, the first function, we differentiate it and we get 3 over 2 x raised to a half when we subtract 1, and this is constant, so it will give us 0, multiplied by 2x squared plus 5x, then plus, now we differentiate this to get 4x plus 5, 4x plus 5 multiplied by the first function, which is x raised to 3 over 2 plus 5. Let's do this. Multiplying this, we have 3 x raised to 5 over 2. Remember that this 2 plus that to be 5 over 2. And then this would give us 15 over 2. 15 over 2 x raised to 3 over 2. 1 plus that should give us 3 over 2. So we are done with this. We come to this one and we are multiplying there. We have 4x 5 over 2. We've just done this. 4x 5 over 2. We now are doing this to get it 20x. 20x. Now this one, we have 5x raised to 3 over 2, and this is 25. So let's see whether we have like terms to collect. Yes, we have this, and this will give us 7x raised to 5 over 2. Okay, so let's see. What about this? This one has also like term here. This is 15 over 2, and this is 5. That gives me 25 over 2. X raised to 3 over 2. Yeah, it's 25 over 2 because, yeah, this plus this will be 25 over 2. Then we have this 4x 5 over 2. So dealt with this, I've dealt with this one and that. So I'm left with this 20x, and then 25. I want to leave the answer at this point, but if you want, you can put it under the same denominator, 2, and you can use the previous example, the way we did the earlier one. Okay, I think this is correct. The 4 is there. Let's just go through it again. This was 3x raised to 5 over 2, and this was 15 over 2, x raised to 3 over 2, using this to be 3 over 2. So this one is okay with the way it is. About this will give us 4x raised to 5 over 2. That's correct. Then this will give us 20x. Then this will give us 5x raised to 3 over 2. Then this will give us 25. So that collecting like terms, this Let's just ensure that we have used all of them. We've added this. We've added this and this. And you got 7x raised to 5 over 2. Then this one with this. And we got 25 over 2, x raised to 3 over 2. And then we have this 20, giving us this. They have used 25. So this 4, we had already used it. So we used it twice. That's why I liked cancelling, so that I do not use something twice. So you can see that I had again included this one here, yet we had already used it. Okay, so this is now correct. This is now correct. 7x raised to 5 over 2 plus 25 over 2, x raised to 3 over 2 plus 20x plus 25. We now look at quotient rule. And I'll begin by stating what it says. And this one we are dealing with a fraction. So if you are given a quotient of two differentiable functions, f of x and g of x, if these two are differentiable, then their derivative is also differentiable. And so how do we get the derivative of this quotient? We get it by taking the derivative of the numerator times the denominator minus the fraction in the numerator times the derivative of the fraction in the denominator, and then over denominator square. So that's how we do it. So you take the numerator, get its derivative, and then multiply by the denominator. You don't differentiate the denominator at this point. Then minus, now differentiate the denominator and multiply by the numerator. Then the whole thing is over denominator square. Let's look at two examples or three. Just enlarge this, that we all can see it. Just do this, then move this one here. Move this one here, then move this one away. Okay. So just enlarge it. So we just use quotient rule because we can see that the functions given to us, a, b, and c, are fractions. So what the quotient rule says is that we will differentiate the numerator. So let me differentiate the numerator, and that numerator, this one is a constant, so differentiating, I only have 2x there. I have 2x multiplied by, just enlarge it again. So it's now clear. So we defined the numerator, and I had said that will be 2x, and then times the denominator. Our denominator is 2x plus x raised to 5. Then minus, now differentiate the denominator to get 2 plus 5 x raised to 4 times the numerator. Everything divided by the square of the denominator. There are several ways you may want to proceed from here. You may want to separate this this numerator and divide each part by this denominator. So you may just want to separate them so that you have this part divided by this, then minus this part divided by this, and then you simplify. You may want to proceed in that way. But the other way is that you may want to expand the numerator and then divide by the denominator. And that's the way I want to do it. So let's just expand the numerator. And so when we do that, we have 4x squared plus 2x raised to 6. This is 4x squared, 2x raised to 6. We are done with this part. So we proceed to this other part. There's a minus. This is 10 plus 2x squared. This is 2x squared. And then this is 25 x raised to 4. And this is 5 x raised to 6. Close the bracket over the square of the denominator. Okay, let's create space here. So again, we continue simplifying our numerator. So this gives us 4x squared plus 2x raised to 6 minus 10 minus 2x squared minus 25x raised to 4. So you should be very keen with the signs here. Negative 10, negative 2x squared, negative 25, and then negative 5x raised to 6 over the denominator square. So we collect like terms from here in our numerator, and I can see that I have this x raised to 2, x raised to 2. Those two give me 2x raised to 2. Then I have this x raised to 6, x raised to 6, and those two will give me 3x raised to 6. Then I have negative 25, x raised to 4, then minus 10, the whole thing over the denominator square. Yeah, that's okay. That's what I was getting. So let me clear this so that we do the other example, and I may leave the last one as the exercise so that you can also have some work to do. So let's just clear this part. So let's look at the second example on the use of quotient rule. So we can simplify the numerator, write it in a manner that is easier. So I can write this as 5. So I want to write the numerator as 5 x raised to a half plus x raised to 3 over x raised to 3 over 2 plus 3. So if I were to simplify this, this is how it will look like. So from here, it's now easier for us to do the derivative. So let's do the derivative of the numerator. So that our g prime of x becomes, this will be 5 over 2 x raised to negative a half plus 3x squared times the denominator, which is x raised to 3 over 2 plus 3, and then minus. This time we differentiate the denominator and get 3 over 2 x raised to a half. When we subtract 1 from this, it's like subtracting 2 over 2. So it would be a half. And these are constants. So multiplied by the numerator, which is 5 x raised to a half plus x raised to 3 over denominator square. And as I said earlier, you may want to separate this numerator and divide each of these parts with the denominator, and then simplify the working. But what I want to do is what I did for the first one. I want to just simplify the numerator and then put it out of the denominator square. Now, so multiplying this by that, so this is for the page 2, it should not confuse us. This is page 2. So when I multiply that, I would have 5 over 2 x raised to, this is 3 minus 1 would be 2. So just x, because this is 3 over 2 minus a half. So it will be x. Then this times that gives us 5 over 2. Then we put the power in the denominator. And put the power x raised to that in the denominator, so that I have positive powers. That's a minute. This one gave us this. So this will give us, supposed to be 15 over 2. 15 over 2. It's this x raised to that I want to put in the denominator. And so if I put it there, it will be raised to a half. If I put it under in the denominator, it will be x raised to a half, because it's a minus here. So we are done with this, and then that. So we come to this, and we get 3x raised to 7 over 2. This is 3x raised to 7 over 2. And then this one is just 9x raised to 2. So let's come to this now. You have 15 over 2 x, 15 over 2x, and it's a minus. And this one is also minus 3 over 2 x raised to 7 over 2, because it's 3.5 over denominator square. And as I said, this one should not confuse you. So x raised to 3 over 2 plus 3 square. So let's do a bit of simplification in our numerator. Bring the like terms together. Can change my pen. This is 5 over 2 negative 15 over 2. Looks like 5. It is 5, because 15 negative 5 minus 15 to be negative 10. So what we're talking about is negative 5x. So we are done with this. So come to the one that has x raised to 7 over 2, this one. So this is 6 minus 3, which is 3 over 2. X raised to 7 over 2. I've skipped this. I'll come back to it. So we'll just use to this. Then plus 9x raised to 2. So let's now do this. This is 15 over 2x raised to a half. Everything divided by our denominator, which is x raised to 3 over 2 plus 3 squared. Somebody may want to leave it like this, but let's go further and put it under the same denominator in the numerator. Our numerator can simplify it further. But somebody may want to stop at that, but there's no harm in going further, so that we have our denominator as 2x raised to a half multiplied by x raised to 3 over 2 plus 3 square. And what will the numerator become? So this would be negative 10 x raised to 3 over 2. This is 3 over 2. This one will go here twice. Go here twice. No, it will go here x raised to a half. So what we'll be having will be 3 x raised to 4. And then here, yeah, because 2 went here, x raised to a half times. So x raised to a half times this is the same as x raised to 7 over 2 plus a half, which is 8 over 2. And then, so we are done with which part? We are done with this. We are also done with this. So we are here. And this is 18 x raised to 5 over 2. And then plus 15. I'll leave it at this point. This will be the answer, the most simplified answer. Okay, let's just again look at it and see. So let's just look at it again. So we began from here. Factorizing, differentiating this, we got 5 over 2. 5 over 2 x raised to negative a half. And this one was 3x squared. And then multiplied by the denominator. Then minus, now differentiate the denominator to get 3 over 2 x raised to a half when you subtract 1 from this into our numerator. So now expanding, we took this times this, it gave us 5 over 2 x raised to 1, because this is 1.5 minus 0.5 to just be 1. Then this times this gave us 15 over 2 x raised to negative a half. So we decided to put this as a positive power. So that meant that we put it in the denominator. It was, what was it? This one times this gave us this. Then this one times that, yes, times 3. This one that gave us 15 over 2. 15 over 2 x raised to a half. That's correct. Then we came to this part times that gave us 3 x raised to, adding this to, you have 5, 7 over 2. Then this times this gave us 9x squared. Then we came to this. This was 15 over 2x. It's negative. This is also negative. 3 over 2x raised to 7 over 2. So up to here, it's okay. So let's just come to where we are simplifying by addition and subtraction and see whether it's correct again. So the first bit, let me now change my pen. The first bit, this one, 5 over 2, we did it with this one, and it gave us negative 5. It gave us negative 5 because we would have, this is negative 7.5 plus 2.5. So it is negative 5x. Then we come to this other part, this part, 3x raised to 7 over 2, and this one. This one is over 2, and this one is not. So this is the same as 6 minus 3, which is 3, and then over 2. X raised to 7 over 2. And then there's this part that I put here. This one I had already used it. So there's this part. Here I put here 15 over 2 x raised to half. So at this point, we said we could leave it as that, or we can go further and put them under the same denominator. So I took these two x raised to half here. So you remember there's a 1 here over 1, then over 1. So this one went here, 2x raised to a half times. So that 2x raised to a half times this, I got negative 10 x raised to 3 over 2. And then this 2 would go here, x raised to a half times. So that means that this x raised to a half times this, I would have 3 x raised to 4. And then of course this would be 18 x raised to 5 over 2, and then this would be 15. Yeah, but you can go through it again and see if it's correct, especially at this point. You can go through it and see. And also you can check here, but I think it's correct. So let's look at the last question. Just create space for the last question. Okay, the last question says 2x raised to 5 minus x over 3x plus 2. Find the derivative of that. So let's find the derivative of the numerator. And this one looks easy. So it will be 10x raised to 4 minus 1 multiplied by 3x plus 2 minus 3 multiplied by 2 x raised to 5 minus x over denominator square okay. Let's just simplify this and we get 30 x raised to 5 plus 20 x raised to 4. This is 20 x raised to 4. This was 30 x raised to 5. There's a minus 1 here. So it will be minus 3x minus 2 minus 6 x raised to 5 plus 3x over 3x plus 2 squared. So simplify the numerator. This will give us 24 x raised to 5. 24 x raised to 5. So we are done with this. And this will give us 20 x raised to 4. We are done with it. And this will give us 0. So minus 2 over 3x plus 2 square. That's how we do that. So that is it for today. So next time we look at derivatives of trigonometric functions, where we'll introduce how to differentiate trigonometric functions. Then after that, again, we'll look at how to use product and quotient rule in differentiating trigonometric functions. Of course, we'll also look at how to do that using definition of derivative.